Hey guys, happy Friday. We made it through week 2 of distance learning. Yeah. Hope you guys are as excited as I am. So today what we're going to do is put into action what you guys read about yesterday in the textbook. And so we're going to take a look at some examples and how we can do that. So let's say that we're going to look at this reaction again where we have some magnesium and we throw that magnesium into hydrochloric acid. Right? And so when we throw that magnesium in the hydrochloric acid, what we see is that it's going to start bubbling. And so let's say that that little strip of magnesium weighed, I don't know, let's say 5 grams, 5.0 grams of Mg. And the hydrochloric acid that we put it in is in excess. So we know what excess means from our reading. And so we know now that my magnesium will be my limiting reactant. And so if we kind of watch this reaction kind of go, we know that hydrogen gas is being produced. Right? So we're going to get some hydrogen gas. Now the question that I want to know is, okay, if we put 5 grams in there of magnesium in the excess HCl, how many grams of hydrogen gas are we actually going to generate? That's the question. If we were to collect all that hydrogen gas that's being formed, how many grams is actually going to be made? And so for this, first and foremost, anytime we work a problem like this, we have to start off with a balanced chemical equation. That's why we did it first. And so we have our balanced chemical equation where we know we have our magnesium. It's going to react with our hydrochloric acid. And when it reacts with hydrochloric acid, we're going to get H2 plus MgCl2 if we pay attention to charges. And then we know to balance it, we're going to need to put a 2 right here. All right. And so, so now what we know is that we have 5.0 grams of this, and this is in excess. And so really the amount of hydrogen gas that we're able to form is going to be dependent solely on the magnesium because we have a finite amount of that magnesium. It is our limiting reactant. And so to do that, right, we're going to say, okay, well, we have 5.0 grams of magnesium. And first thing we want to do is go into moles, right? So for every 1 mole, we have 24.31 grams. And now it's going to give us 0.206 moles of magnesium. Well, moles of magnesium is great, but we're looking for hydrogen. So the next step is we have to kind of figure out, well, if I have that many moles of magnesium, how much hydrogen am I going to make? And that's where the balanced equation comes in, because the balanced equation tells me that for every 1 magnesium that I react, I make 1 mole of hydrogen gas. So if I react 1 mole of magnesium, I'm going to make 1 mole of hydrogen gas. And that gives me my mole ratio and that relationship between magnesium and hydrogen in this case. And so if I look at this, we now remember where we've been, we put on the bottom. So for every 1 mole of magnesium, so those things can cancel, I'm going to get 1 mole of hydrogen gas. And so those would cancel. That would give me my 0.206 moles of magnesium. And then once I have that, my 0.206 moles of I lied over here. That's not magnesium because we mole ratioed it, we turned it into hydrogen gas. So now I have that many moles of hydrogen gas, but I don't want moles, I'm looking for grams. And so now I know that for every 1 mole, I have 2.02 grams. And so this is going to give me a whopping total of 0.415 grams of H2. So that's how many moles of H2 I would be able to make. Now, so that's pretty simple, right? So 3 steps, we're used to doing those 3 steps. Nothing's changed except for this step here, right? That mole ratio now comes from our balanced chemical equation. Now, this works well, right? I could say, okay, if I have that many grams of magnesium, how many grams of hydrochloric acid would I need to react with it? How many grams of magnesium chloride could I make? Whatever, right? We can go back and forth. If I want to make 5 grams of magnesium chloride, how many grams of hydrochloric acid would I have to make? All of those things are related, and we would do them exactly the same way. Now, we have something slightly different, right, here, where we can have another pretty cool reaction. And this time we have ammonium perchlorate. And so ammonium perchlorate is going to have, I'm going to go red, is going to have a formula of NH4ClO4, and we're going to react that with aluminum. And so if we kind of take a look at this reaction, right, I'm gonna speed it up so we can see it here, right, because it works a little bit better. It's an exothermic reaction, and it's a really violent reaction. They actually use it for rocket fuel. So you can see kind of it took off. Not one I would be doing in a laboratory. And so let's just say that if we look at this, now I want to say, okay, well, let me say that I take 15.0 grams of aluminum and I reacted it with 15.0 grams of the ammonium perchlorate. So this is a little bit different problem because now we have a finite amount of both reactants, and we don't know necessarily just by looking at it which one's going to be limiting. And so we have to figure that out because we have a finite amount. We don't know which one's in excess. We don't know which one's limiting. And so again, to do this, the first thing that we're going to do is we're going to have to start off with our balanced chemical equation, right? And so here we would have aluminum is going to react with NH4ClO4. This one's a little bit more complicated. It's not just a simple single replacement. We actually get Al2O3 plus AlCl3 plus NO plus H2O. And so not going to spend a lot of time kind of working through this. To balance this, we would need a 3 here, a 3 here, a 3 here, and actually a 6 over here. So there's our balance equation. Again, first thing we need to do is start off with our balance equation. Now, since we have a finite amount of both things, we have 15.0 grams here and we have 15.0 grams here. And in this reaction, let's say we want to know how much aluminum chloride we could potentially make here. So how many grams of that aluminum chloride would we make in this particular reaction? And so what we have to do is, since we have a finite amount of both reactants, we actually have to do two calculations, one with aluminum and one with the ammonium perchlorate. And so that would kind of look the same though. We'd start, okay, we have 15.0 grams of my aluminum. We know that aluminum, for every 1 mole of aluminum, there's 26.98 grams. And that's going to be equal to 0.556 moles of aluminum. And now we can say, okay, well, we can do our mole ratio, 0.556 moles of aluminum. And then our mole ratio now again, right, we see that for every 1 mole of aluminum chloride that we produce, we need to react 3 moles of aluminum. So our mole ratio in this case is going to be 3 moles of aluminum, because we want it to cancel, so we put it on the bottom, for every 1 mole of my AlCl3 that I'm able to make. And so if I do that, that's going to be 0.185 moles of AlCl3. Now, this is a good stopping point. This is what the book said to do, is they kind of stop here for the moment. And so now we know that if we react all 15 grams, if that all goes away, the maximum amount of aluminum chloride we can make is 0.185 moles. Okay, so let's see how that compares to the ammonium chlorate if it all would go away. So we'd have 15.0 grams of my NH4ClO4. Again, for every 1 mole, in this case my molar mass is 1.5 grams, and that's going to give me 0.148 moles of my NH4ClO4. Now, so then my 0.148 moles, and I look up in my balance equation again, it's the same mole ratio here, so I still have 1 there, but now I also have 3 there, so it's the same mole ratio. Just by happenstance, it's not always the case, but it is in this problem. So I have, for every 1 mole of AlCl3 I want to produce, I react with 3 moles of my NH4ClO4, and that's going to give me 0.0493 moles of my AlCl3. So now if all 15 grams of this go away, the maximum amount I can make is that. Conversely, if all 15 grams of this goes away, I can make that many moles. So in this case here, right, the reaction is going to stop as soon as I make 0.0493. The reaction is going to stop at that particular point. And because at that point, as soon as I make this, I run out of this. So I will never be able to get to that point. And so right here, this is going to be how much I make. And what we're going to see later is this is going to be my theoretical yield, because it is what I can make in theory, right? That's the maximum amount I can make. And so now, but I wanted grams. And so in order to get to grams, I can finish the problem. Now that I know how many moles of AlCl3 I can make, I'm going to say 0.0493 moles times, and in this case, it's 133.33 grams of AlCl3 per mole. And that would be my 6.57 grams of AlCl3, and that would be my answer for this problem. So I hope that all makes sense. Let me know if you have any problems. I hope you guys have a great weekend. Get some rest, get outside, and just get some exercise. I can't wait to talk to you on Monday. Peace, love, happiness. Thanks for playing.